A quick review on the pumping lemma for context-free language. Uh, Pumping lemma is to check whether the language is context-free or not. So first, let us assume that the language is context-free. Take a particular string z, let the string be of finite length, and we'll divide this string as 5 different substrings where the middle part vwx should be less than or equal to n, and vx, the prefix and the suffix what we choose should be greater than or equal to n. Populate uh, v, sorry, this part is v wx for I v and x for 5 times, I times, and then prove whether it is a language or not. Now we'll just go through an example where I have taken a per n, b per n, c per n. U alone is considered to be a per n, c per n I have taken it at y, vwx, the middle part, is considered as b per n. Now, VWX put together is B per N. W, I have taken it to be B per M, where M is less than N. And our condition says the length of Vx put together has to be greater than or equal to 1. Since this is all B per N, uh, we would like to take V and X. uh, W is B per M. Therefore, the remaining is N minus M, and therefore Vx is B per N minus M. Now, populating it, U V to the power I, W x to the power I y. U W, I have taken it since the order my, might will not vary because we are only considering the sequences of B. I have pulled out W to the left, brought V and X together, and then with an to the power I. Now substituting I to be 0, you will have A per n, B per m, C per n. When I is 1, this you have B per m, B per n minus m and m gets cancelled. You have the string language. When I is 2, you'll have something which is not to the per n, and therefore a per n, b per n, c per n is not CFL. Here you have another question which says a per n, b per m, n and c per I, but here I and n are dependent. You can connect with a per n, b per n and c per I, and then check whether this is not part of CFL or not. Now, how will I do it? You take A per N to be U, C per I to be C, VWX, we'll take it as B per N. W, let me take it as B per uh, I. Okay, so that we'll match it with this particular I, and the rest is b per n minus I. So you populate it for different number of times, and at one point of time we'll find out I exists, uh, but then we can never prove a per n and b per I are same, and therefore by hypothesis this is not an CFL. And now again, WW, you can never prove the strings whatever you have here comes on the other side. So you take equal number of a's, equal number of sorry, you have a ab combination, and say at half of the string, the second half of the string is considered as C. The first half of the string, suppose you have ab as a string, the first A you consider it as U, or if you have to take VWX, you can always take sequences of AB, okay, and then try to prove that that is not part of the language. Just take a sample example as sorry, as 3 A's with 2 B's, and then again 3 A's with 2 B's. Okay, this 3 A's with 2 B's, we'll take it as A. The next 3 A's, we'll take it as VWX, and the last 2 B's, we'll take it as C. And then we do population, you will end up in a not CFL language. So in the third case, you can take an example. Similarly, in the first case also, you can take an example if you want, or you can prove by hypothesis. If you have any clarifications, you can ask.